Welcome to an in-depth exploration of climate change. Today, we'll journey through the science, history, and societal impacts of this pressing global issue. Climate change is more than just a buzzword, it's a complex phenomenon that has shaped our planet for billions of years. By understanding its definition, origins, and the debates surrounding it, we can better grasp why it matters to every inhabitant of Earth. Let's begin by defining climate change and setting the stage for our discussion, connecting the dots between natural laws, human activity, and the ever-changing environment. Truly understand climate change, we must first define it. Climate is typically described as the average weather at a particular place, while change means to make or become different. When combined, these terms describe the ongoing shifts in Earth's climate patterns. Scientists have long studied how geological and atmospheric laws, like Earth's rotation and internal processes, affect climate. But in recent centuries, human society and the industrial age have added new variables to the equation, raising questions about who or what truly controls the climate: nature or humanity. Earth's climate has always been governed by natural laws, geological and atmospheric forces that operate over immense timescales. The planet's rotation, volcanic activity, and solar influences have shaped climate for billions of years. Scientists from various fields, including geology and oceanography, have documented these effects. However, the rise of human civilization and industrialization has introduced new factors, making it crucial to distinguish between natural and human-driven changes. This interplay sets the stage for ongoing debates about the true drivers of climate change. Central argument in climate change discussions revolves around greenhouse gases, especially carbon dioxide, methane, ozone, and chlorofluorocarbons. Historically, these gases were produced by natural phenomena like volcanic eruptions and solar activity. However, recent decades have seen a sharp increase in emissions due to industrial processes. Scientific evidence now points to human activities as the dominant force behind the current warming trend, with greenhouse gases absorbing and emitting heat, altering global temperatures and weather patterns. Understanding how greenhouse gases function is key. These gases absorb and emit radiation within the thermal infrared range, trapping heat in Earth's atmosphere. This process warms the planet's surface, affecting everything from ocean temperatures to weather systems. While natural processes like volcanic activity also contribute heat, the scale and speed of recent changes point to human influence. Scientific consensus is clear: human-generated greenhouse gases are the primary cause of modern global warming. Earth's climate has a 4.5 billion-year history marked by dramatic shifts and hardships. Scientific discoveries reveal that regions like Antarctica were once lush and green, with polar forests thriving during greenhouse intervals. These changes, driven by natural forces, highlight the planet's dynamic nature. By studying past climate variations, we gain perspective on the current warming trend and the unique challenges posed by the industrial age. The debate continues over how much recent changes differ from those in Earth's deep past. One of the most pressing concerns linked to climate change is sea level rise. As global temperatures increase, glaciers and ice sheets melt, causing oceans to swell and threatening coastal ecosystems worldwide. Scientific studies show that rising seas can lead to extreme weather, flooding, and loss of habitat. Indigenous communities, like the Arctic Inuit, offer valuable insights into these changes, emphasizing the importance of local knowledge in understanding and adapting to climate impacts. Climate change is a global issue, affecting diverse regions in unique ways. In Mexico's Yucatan Peninsula, rising sea levels threaten coastal hammocks, while in the Himalayas, glaciers are retreating due to warming and rainfall. Each location faces its own set of challenges, from flooding to ecosystem disruption. Understanding these regional differences is essential for crafting effective responses and recognizing that climate change's effects are not uniform across the globe. Today's extreme weather events truly unprecedented, or are they part of Earth's natural cycles? Scientific reports offer mixed conclusions. While some studies find no clear evidence of increased global climate variability, others highlight the role of human activity in intensifying certain events. The debate underscores the complexity of distinguishing between natural planetary behavior and human-induced changes, reminding us that climate science is an evolving field. Adaptation is a recurring theme in climate discussions. Throughout history, both ecosystems and human societies have adjusted to changing conditions. However, the speed and scale of modern changes pose new challenges. Research shows that adaptations to normal climate differ from those required for rapid climate change. As we face uncertain times, science and innovation will play critical roles in helping societies adapt and thrive in a changing world. Earth's climate operates on three continuums: geological, atmospheric, and societal. As humanity advances alongside these natural forces, we must balance concern with rational action. The widely discussed 2-degree threshold should not incite panic, but rather inspire focused efforts on issues we can address. By targeting damage control and supporting vulnerable communities, we can make meaningful progress while acknowledging nature's enduring influence. Marshall Islands exemplify the urgent need for climate adaptation. As rising seas threaten their very existence, innovative building technologies and sustainable practices become essential. These islands serve as a template for future responses to sea level rise, highlighting the importance of leadership, planning, and international cooperation. The fate of such vulnerable regions raises critical questions about relocation, support, and global responsibility. Throughout history, Earth has oscillated between two dominant climate states, greenhouse Earth and icehouse Earth. These long-term cycles driven by natural forces have shaped the planet's environment and life forms. Today's inhabitants, equipped with intellect and technology, are attempting to influence these cycles. The debate continues over whether human actions can truly alter such powerful natural processes, or if we are simply responding to forces beyond our control. Historical records reveal that climate fluctuations have often coincided with major societal changes, such as population shifts, wars, and even social injustices. By examining archives and scientific data, historians like Mark Carey have shown that past climate episodes were sometimes as extreme as those we face today. These insights remind us that climate change is not a new phenomenon, but the context and consequences are evolving. Public discourse around climate change can sometimes veer into hysteria, driven by fear rather than logic. History warns us of the dangers of letting emotion override evidence, as seen in past episodes of social panic. A balanced approach, grounded in science and open dialogue, is essential for making sound decisions about climate policy and action. Leaders and scientists often treat Earth as a patient, diagnosing its climate health through careful examination. Over 4 billion years, the planet has experienced countless fluctuations, driven by natural engines of change. The question remains, is Earth a force of nature that cannot be tamed, or can human intervention make a meaningful difference? By studying both natural and human-driven changes, we can better understand our role in shaping the future. Earth is divided into 3 main climate zones: tropical, temperate, and polar. Each zone contains unique ecosystems and life forms, shaped by local climate conditions. Studies like Darwin's work on the Galapagos Islands highlight the diversity and adaptability of species within these zones. However, rapid changes, such as permafrost melt in Siberia, pose new risks to both natural and human systems, underscoring the need for ongoing research and adaptation. Permafrost, ground that remains below freezing for years, underpins many polar regions. As climate warms, permafrost thaws, threatening infrastructure and ecosystems. Russian scientists have documented the profound effects of permafrost melt, from structural damage to economic disruption. These changes highlight the interconnectedness of climate, land, and human society, and the urgent need for preparedness in vulnerable regions. Oceans play a crucial role in Earth's climate system. Layers of sediment on the ocean floor record past climate events, offering clues about ancient greenhouse worlds and mass extinctions. By studying these records, scientists can trace the interplay between marine life, mineral deposits, and climate shifts. This research helps us understand how current changes might echo or differ from those in the distant past. Human activity has introduced foreign species to new habitats, sometimes with unintended consequences. In places like Brazil's Cerrado, African grasses have replaced native landscapes, altering local ecosystems. Similar patterns are seen in the United States, where non-native plants and trees reshape environments. These changes can disrupt natural balances, highlighting the complex relationship between human expansion, biodiversity, and climate. Sedimentary deposits, like those studied in Sockley, Fennoscandia, provide invaluable evidence of past climate changes. By analyzing layers of sand, silt, pollen, and minerals, scientists can reconstruct thousands of years of warming and cooling events. These records help us identify the causes of climate change, distinguish between natural and human-driven factors, and inform future strategies for adaptation and mitigation. Key challenge in climate science is measuring the relative contributions of natural and man-made greenhouse gases. While industrial activities release significant amounts of carbon dioxide and other pollutants, natural processes, like volcanic eruptions and permafrost melt, also play a role. Accurate assessments are essential for crafting effective policies and protecting vital resources like the ozone layer, which shields life on Earth. As stewards of the planet, humanity faces the dual challenge of managing both progress and environmental well-being. Cleaning up waste and reducing pollution are important steps, but they are not the only factors influencing climate. Scientific research and open-minded exploration are needed to identify all causes of climate change, ensuring that solutions are comprehensive and effective. Climate change is a slow, methodical process, distinct from abrupt weather events. Geological and fossil records show that Earth has undergone cycles of birth, extinction, and rebirth, with climate at the helm. These cycles have shaped the evolution of life and the development of civilizations, reminding us that change is a constant feature of our planet's history. Leading ecologists like Dr. Crystal Mantica Pringle emphasize that the combined effects of land use and climate change may exceed our ability to intervene. Once certain thresholds are crossed, our capacity to reverse or mitigate changes becomes limited. This underscores the importance of proactive management and the need to respect natural limits in our efforts to protect the environment. Distinguishing between natural planetary variations and human-induced changes is crucial for understanding climate change. By identifying the sources and effects of different factors, we can develop logical responses to global challenges. This clarity helps avoid confusion and supports more effective decision-making in policy and daily life. Milankovitch cycles describe how Earth's orbital movements, eccentricity, and axis tilt influence long-term climate patterns. These cycles affect the planet's absorption of solar radiation, leading to periodic ice ages and warm periods. Understanding these natural rhythms helps scientists separate background variability from recent human-driven changes. Greenhouse gases and fluorocarbons have significant impacts on atmospheric systems, including the ozone layer. These substances contribute to rising temperatures, and in some cases, the formation of superstorms. Protecting the ozone and managing emissions are critical steps in safeguarding the planet's health and stability. Earth's surface and deep geological processes, like volcanic activity, plate tectonics, and seismic events, continuously reshape the planet. These forces can trigger natural hazards and influence climate patterns. Scientists are investigating how these deep processes interact with surface conditions, adding another layer of complexity to climate science. Sun's energy, generated by nuclear fusion, is the primary driver of Earth's climate. Over billions of years, the sun has grown more luminous, affecting the planet's temperature and biological chemistry. Fossil records suggest links between solar radiation, extinction events, and greenhouse conditions. Understanding these connections is vital for predicting future climate trends. Climate change threatens biodiversity worldwide. Groups like freshwater mussels are facing extinction due to shifting temperatures and altered ecosystems. Protecting these species requires identifying the environmental factors at play and implementing targeted conservation strategies. The loss of biodiversity has far-reaching consequences for ecological balance and human well-being. Not all effects of climate are negative. In the Ecuadorian Andes, communities have adapted to deforestation by replanting timber and revitalizing land. These positive responses demonstrate human ingenuity and the potential for turning challenges into opportunities. Historical examples, like the economic booms driven by favorable climates, show that adaptation and resilience are key to thriving in a changing world. Vulnerability and adaptability are central to understanding climate impacts. Different countries and regions vary in their ability to respond to rising sea levels, extreme weather, and resource shortages. Effective adaptation requires tailored strategies, international cooperation, and a clear understanding of local risks and capacities. Sea level rise, driven by melting ice sheets and thermal expansion, poses significant risks to coastal communities. Some countries may struggle to adapt, especially those with limited resources or vulnerable infrastructure. The intrusion of saltwater into agricultural lands can threaten food security and destabilize regions, highlighting the interconnectedness of climate, economy, and society. Effective land and water management are crucial for adapting to climate change. In the United States, practices like damming rivers and overusing groundwater have created new challenges. Balancing productivity with sustainability requires innovative approaches to sediment redistribution, water conservation, and disaster preparedness. Ensuring safety and security in the face of climate change means protecting vital resources like groundwater and arable land. Natural disasters, such as the Dust Bowl of the 1930s, demonstrate the long-term impacts of poor land management and extreme weather. Learning from history can help societies build resilience and safeguard their future. Research shows that climate change and land use practices are having substantial impacts on biodiversity. As habitats are altered or destroyed, species struggle to adapt, leading to declines in population and ecosystem health. Better planning and restructuring of human settlements can help mitigate these effects and promote coexistence with nature. Transitioning to clean energy is a key strategy for addressing climate change. Combining carbon and carbon-free sources, like solar, coal with carbon capture, and nuclear power, can provide reliable, manageable power while reducing emissions. Science supports the idea that clean energy can help stabilize global temperatures and protect the environment. Constructive approach to energy consumption involves integrating solar, nuclear, and coal with carbon capture into residential and community design. By tailoring energy sources to local needs and geography, communities can achieve economic and environmental benefits. Sustainable energy is essential for health, productivity, and national security. Nuclear power provides a significant share of energy in developed countries, offering low carbon emissions and reliable output. However, challenges remain in waste management, safety, and public perception. Innovations in reactor design and site selection are needed to address these concerns and unlock the full potential of nuclear energy. Solar energy is becoming increasingly competitive, with large-scale installations powering thousands of homes. The concept of grid parity, when solar becomes as affordable as conventional electricity, drives investment and innovation. However, solar's dependence on sunlight means it must be complemented by other sources to ensure reliability during emergencies or prolonged cloudy periods. Coal has powered industrial revolutions and remains a major energy source. Advances in carbon capture technology and stricter environmental regulations are making coal cleaner and safer. The industry's history is marked by both progress and tragedy, emphasizing the need for unified efforts to ensure safety, sustainability, and responsible management. No single energy source can meet all needs. A balanced approach, combining solar, coal, and nuclear, offers the best chance for reliable, clean, and secure energy. This strategy can reduce emissions, stabilize temperatures, and support economic growth, provided it is implemented fairly and inclusively. Good energy plan requires action, not just ideas. By investing in available technologies and fostering innovation, societies can create economic opportunities and environmental benefits. As debates continue, it's important to focus on practical solutions that include all stakeholders and avoid divisive rhetoric. In conclusion, climate change is a multifaceted challenge that requires both stewardship and innovation. By embracing a balanced energy strategy, respecting natural limits, and supporting vulnerable communities, we can build a more sustainable future. Let's continue to listen to science, learn from history, and work together to protect our planet for generations to come.